These are very old doors with very old hardware. Namely, they are pivot hinges looking like so. Servicing these can really be a bit of a misery because new parts are not available. These are so old. But new parts may not be needed. As the hinges wear over time, you can see this scrape mark on the floor. Sometimes the bottom of the door starts scraping the floor. This one is okay-ish. So over time, as the hinges wear, the door might start scraping the floor, like in this situation here, you can see the scrape marks there. And this type of door's hinge is set into concrete, looking like this. Now, what happened in this particular case, in about 1958, when this was installed, it got installed this way. So this pivot point here has been loose and rattly since 1958-ish. So let me show you how this looks like when it's correctly assembled. This lead sleeve that deforms needs to be in place on this bolt, and then this wedge needs to be on the bolt correctly oriented this way. So that's how the correct assembly looks like, and of course it needs a hole that's big enough so that this drops in to begin with. The diameter of this sleeve is about that many millimeters or inches, and it looks like a 7/8 drill bit would drill a hole big enough for this. Now this is the upper half of this bottom hinge, and this is what you see most often. What's not obvious is that this is a thrust bearing that's supposed to spin there, and this is how it looks like when it's seized up and all the rolling elements collapsed in it. So this can be pulled with a bearing puller or a helpful millwright, because the casting doesn't need to be replaced. The manufacturer threw this casting away in 1978, and so you're not getting more of these. So the screw hole pattern is important, of course. The offset distance here is important, but these bearings are available widely. On the lower half of the bottom pivot, none of the parts are proprietary. This is a very common bolt with a standard thread pitch size, a lead sleeve, and a wedge that threads onto the bolt. None of these are proprietary, very common. This component here, this is the surface where the bearing ball, the thrust bearing ball elements roll. This could be easily remade by a competent machinist or millwright in their first year of their apprenticeship, seriously, but it does need a chunk of metal this is originally made out of. How this works is very, very straightforward. You drop all this into the floor, a correctly sized hole, 7/8 of an inch here. That's a little too big, so it drops in, and tighten the bolt. As you spin the bolt, the sleeve and the wedge is getting closer and closer to the washer and the head here. There, it's getting tight there. So that's how they look like. And when it's fully tightened, it's obviously going to split the 2x4 there. Just friction fit there. That's how it looks like. And just needs proper tightening. And during tightening, this wedge is expanding this lead sleeve a little bit, and that friction is going to split this 2x4 obviously, but that's what's holding it in place, centered and plumb if the hole is drilled in plumb to begin with. These thrust bearings are widely available and can be fitted in by your friendly millwright. And welcome to the world's smallest concrete pour. Yeah, I mixed it in this bowl. And that's my stir stick. And it's gonna be good in a few hours. Obviously, this is my spacer. Just moving it around so I can pull it out without cracking. The quickcrete is here. And yes, this bottom pivot point here will be greased as well as this surface, but the majority of the rotation should come from the thrust bearing just turning in its place. That's already internally greased and sealed. But yeah, I'm gonna add a little extra here. Butter smooth. I'm not gonna do anything with the rolling element on the bottom pivot point. Its surface here in contact with the thrust bearing is highly polished, and that surface is not failing. Yes, it is worn, and yep, it's gonna work just fine. Same applies to the top hinge and the top pivot point. If you back out this screw, then the pin will come out from the hinge. The pin is running in a brass bushing, looking like so. On this side, this is the top side of the top pivot, and this is a bearing that turns. And of course, this pin is in it, like so. So let's see how much play we have here. Quite a bit, quite worn, but I'm not gonna replace either the bearing nor the pin. The pin is scratched, possibly, obviously, smaller in diameter than it used to be. The weight of the door is on the bottom, that's where it matters. And the top is just holding the door from folding over. So I'm not too concerned about the condition or the age of the play in this assembly. It's gonna work fine. Some of these screws will be replaced though. This is acceptable. The thread on it is not busted, and these three are all garbage. We'll change the threads in the door just in case they weren't made properly, or just in case these contributed to damaging the threads somehow. I want all four obviously solid with intact threads, because if these are gone in the door, that's a whole lot of welding and whatever to make this work again. Yeah, and it's working. And I think I've hit pay dirt right here. These ones will work. We even have the shorty ones to replace if we want to. This went in nice, so let's tighten it. Oh yeah, this tightens nicely. There. It doesn't have to be super tightened. The door is going to be resting on it fine. And more importantly, or most importantly, it's not moving. Previously, somebody tried to compensate for the loss of height in the hinges and the scraping of the door on the floor by placing these two extra washers into the middle hinge here. How did that work out? Obviously it didn't, it's scraping the floor. So this could work, but not this time. Unfortunately, putting a washer or two here is completely unnecessary, because this part of the door here, this whole pin is threaded from below and can be simply turned with a flat screwdriver like that, and can be raised. Once this set screw here, this one is out of the way. And let's have one more look at this in good daylight, and then I'll explain what that is. So the little Allen key goes there, the big screwdriver goes here, and the two halves work together really smoothly, because the upper half also has a bearing when everything is cleaned up, and is replaceable and can be lubricated. And like I said, if you spin the screwdriver, this raises the height of the door. Now, why I have these cuff marks on it is because it's rubbing the door right there, because these hinges obviously only work when the center point of this rotation lines up exactly with the center point of the rotation at the top hinge, goes through the middle hinge, and lines up with the bottom hinge or bottom pivot on the floor. And the one on the floor is out by about 5 millimeters. So that's why between the top and the middle, at 2 points always define a straight line, but the third point has to be also on the same line, so which it isn't, so it needed a little bit of sanding. So that's what's involved. That bearing is replaceable. The pivot point can be lifted and will last decades. And it's time to grease it up. The custom ground middle hinge looks like that. You've seen the top, you've seen the bottom. The door opens and closes as it should. And,